Teaching math and learning to teach math don't tend to happen at the same time. However, typical professional development doesn't provide adequate training on the contingencies faced by teachers in their classrooms. Schools and districts all over the United States want to improve mathematics instruction, and there are significant investments being made towards realizing this goal. But even so, the best methods for improving math instruction remain difficult to implement, which can drastically affect a teacher's ability to plan strategically and respond to contingencies in the classroom. Project Sigma, or the Supporting Instructional Growth in Mathematics Project, is a research-practice partnership between researchers at Vanderbilt University and a professional development organization, Math for America Los Angeles, funded by the National Science Foundation. Together, they are looking at the need for better professional development processes for math teachers. Traditional methods of professional development isolate particular aspects of classroom life and focus on them as individual parts that make up the entire classroom experience. But in a live classroom environment, teachers must take on every aspect of the classroom at once. Classrooms are socially complex, and so when problems arise, teachers have to try new things. But bringing research-based teaching practices into classrooms is a complex act of synthesis, and things can easily go wrong, and the teachers are left wondering whether they did a good job. Sigma highlights that according to multiple studies, high-quality professional development depends on several factors, including a focus on content knowledge, opportunities for active learning, and sustainability. Sigma's approach to addressing these issues is through design-based implementation, which allows for iterative work on persistent educational issues. This is achieved through interactive collaboration between researchers, teachers, and our professional development partners, using their respective expertise to develop theory and improve practice. Prior to the lesson, researchers and the teachers identify something the teacher is trying to work on. Coaching conversations use video gathered from real teaching scenarios. Video is gathered in classrooms via 2 cameras and 4 microphones placed in student groups, 1 camera recording the classroom and another camera recording the teacher as they move around the classroom. The research team facilitates a conversation around selected clips of video and audio to promote teachers' reasoning and sense-making about teaching. Feedback allows the teacher to reflect, be thoughtful, and consider other approaches to what happens in their classroom. Sigma's research is making more ecologically valid recommendations that can be transferred to live classroom scenarios. The project proves that the acquire-apply notion of translating education research into actual practical teaching is an oversimplification. Bringing good teaching practice into real-life classrooms is actually an extremely complex process, and professional development must reflect this.